Hi, my name is Jamie Redding, and I'm a program manager on the SQL Server engineering team. In this session, I'll be discussing the architecture and performance features of SQL Server 2017 on Linux. A little of my background. I spent about 34 years in the computing industry, primarily focusing on systems and database performance. I've been at Microsoft almost 20 years now. I also serve as Microsoft's rep on the TPC, and I'm a member of the TPC steering committee, and I also chair the TPC Technical Advisory Board and the TPC Pricing Committee. In this session, we begin by looking at how we enabled SQL Server on Linux and the underlying architecture. Next, we'll discuss several performance features found in SQL Server 2017. We'll also cover some Linux-specific tuning settings that you can use to gain the best performance. And finally, we'll look at some performance numbers and proof points. With SQL Server 2017 on both Windows and Linux, we continue to provide the fastest general-purpose database on the planet. We have consistently demonstrated this performance across both OLTP and analytic workloads. These results were done with close collaboration with our hardware partners and use a suite of TPC benchmarks. But best of all, SQL Server 2017 on Linux is just SQL Server. That enables us to maintain similar levels of performance on both Windows and Linux. We also found some code out of Microsoft features called Drawbridge. This was designed for process isolation. We took their code, looked at it, and realized they did some very brilliant work there. They have mapped all the API calls in Windows down to about 50 binary interface calls. So we combine SQL OS and Drawbridge into something called the SQL Platform Abstraction Layer, or SQL PAL. So now we can have SQL Server running on top of a very small number of Windows binaries. SQL Server doesn't know any difference and still thinks it's running on top of Windows. So there's no need to write a lot of code. There are a few code paths that are performance critical, like disk and network I/O. For those functions, we wrote more direct code paths to ensure performance. So now we have SQL Server sitting on the PAL, sitting on Linux with minimal code changes. Not only does this perform it also helps with code quality. Anytime you have to write a bunch of code, the chances of error creeping increases. So the same SQL Server code will run on both Windows and Linux. It's the same version on both platforms. This means when we fix a bug or add a new feature to SQL Server 2017, they appear on both OS platforms. Remember, it is just SQL Server. Now we'll look at a few performance features that are either new or enhanced in SQL Server 2017. We'll look at adaptive query processing, automatic soft NUMA, automatic tuning, column store indexes, the database tuning advisor, and finally, in-memory OLTP. Adaptive query processing is new in SQL Server 2017. It's made up of three components. There is the batch mode memory grant feedback, batch mode adaptive joins, and interleave execution. The batch mode memory grant feedback monitors the memory asks and grants from queries, and if a grant is not correctly sized for the query, performance will suffer. Insufficient memory grants will force the query to spill to temp DB, also hurting performance. If the grants are too high, other concurrent queries will suffer due to wasted memory. When you repeated queries, SQL Server 2017 will track and revise these memory grants to ensure the best performance across the system. The batch mode adaptive join technology allows SQL Server to defer the selection of a hash join or nested loop join until after the first input data has been scanned. Based on the initial scan, the query processor will dynamically change the query plan to use the optimal plan. Workloads with frequent oscillations between small and large join input scans will benefit most from this feature. And finally, we have interleave execution. Part of SQL Server 2017, when a query utilized multi-statement table valued functions, the number of rows to process was estimated, either 100 for SQL Server 2014 or 1 for SQL Server 2016. These set values could result in the wrong selection of join operators and memory grants, which hurt performance. This feature adjusts the execution plan by executing a part of the query first and then redesigns the query upon the fly based on the actual number of rows returned. This leads to a much better execution plan and better query performance. Automatic query tuning is an evolution based on the query store we introduced in SQL Server 2016. Automatic tuning is a process that continuously monitors and analyzes your workload to learn its characteristics and identifies the potential issues and improvements. This feature capitalizes on learnings from monitoring databases in the Azure SQL database. This process allows the database to dynamically adapt to your workload by identifying what indexes and plans might improve performance, and conversely, what indexes might be negatively affecting your workload. Automatic query tuning applies the tuning actions that will improve performance. It then monitors the changes to ensure they actually improve performance. If it finds a modification that didn't improve performance, then that change is reverted back to the previous behavior. Part of this process is automatic plan correction. This feature identifies SQL Server query plan choice regressions and then fixes them automatically. Since we keep previous plans, we can force the last known good plan to be used. This feature will also monitor the performance of the forced plan. If the forced plan is not better than the regress plan, the new plan will be unforced and SQL Server will compile a brand new plan for you. If SQL Server verifies the forced plan is better, then that one will be used until recompile is done later. The column store was introduced in SQL Server 2012. Over the releases since then, there have been continual enhancements to this technology. The column store index flips the data out of the traditional row-based storage into a columnar format. Column store indexes are incredibly powerful for decision support and analytics queries that need to scan and aggregate large amounts of data. The column store compresses the data, which reduces the memory and disk footprints. Data can be compressed up to 10x. Column store indexes also filter scans by eliminating row groups and segments that are not needed to satisfy the query, which increases the query performance. The gains of column store indexes can be experienced with little or no modifications to your queries. Database Tuning Advisor analyzes the workload and how one or more of your databases are set up. Tuning Advisor uses trace files, trace tables, or T-SQL scripts as a workload input. You can create a trace file and trace table workloads by using the tuning template in the SQL Server profile. So after analyzing a workload, the Database Tuning Advisor can make recommendations on changes you can make to the actual physical structure of your database. It will also look at the data statistics that might be required to supplement the physical database structures. These structures are things like additional or modified clustered and non-clustered indexes, indexed views, and data partitioning. The end goal of the recommendations are to reduce the query optimizer's estimated cost of the workload without changing the query at all. In SQL Server 2017, we continue to enhance the in-memory OLTP support. We've added support for computed columns and memory-optimized tables, and the ability to create an index on these columns. This allows transactions to use predicates on these computed columns to improve performance. Though not completely performance-focused, SQL Server 2017 also provides full support for using JSON functions and natively compiled store procedures. We also implemented a cross-applied join with table value functions. So there are some basic starting points for tuning both SQL Server 2017 and the underlying Linux operating system. The same tuning suggestions we use for SQL 2017 on Windows apply to SQL 2017 on Linux. One of the big differences is that when running on Linux, you have more control on how much memory is available for SQL Server 2017 to use. The value is set by using the SQL configuration script msqlconf on Linux. By default, SQL Server is granted 80% of your physical memory on the system. If your system has a large amount of memory installed, that 20% value may be significant, especially if the system is dedicated to SQL Server. You can increase the amount of memory available to SQL Server by passing a new value to msqlconf. One caveat though, dedicating too much memory to SQL Server can starve other Linux processes. At a bare minimum, you should leave at least 3 to 4 gigabytes of memory for the rest of the system. For the Linux OS itself, you should set the kernel settings for high performance. These may be different depending on the distro Linux you're using. The best practice is to consult the distro documentation to ensure you have the proper high-performance settings enabled. In addition to kernel settings, we suggest you disable the auto-NUMA balancing on multi-node NUMA systems. This prevents the OS NUMA from conflicting with the SQL Server NUMA balancing. You should also leave transparent huge pages enabled, which allows SQL Server to use large data pages in memory. And finally, if you're running SQL Server 2017 on Linux instead of Linux virtual machine, you should configure a fixed amount of memory to be reserved in the virtual machine. Not doing this will cause significant performance issues. So, how do all these features and tunings relate to the overall performance of the system? Well, we use these tunings and settings to produce several performance proof points throughout the year of 2017. At the Ignite 2017 conference, we showed a video of SQL Server 2017 running on Linux, executing a table scan on a 180 billion row table. The underlying hardware had 480 CPUs, and we were able to drive all the CPUs to 100% and scan the 180 billion rows under 20 seconds. Now, in partnership with HPE, we published 2 separate TPCH benchmarks using SQL 2017 on Linux. The first result was an HPE ProLiant DL3 Gen 9 using Red Hat Enterprise Linux. This result was about 5% faster than the result published on similar hardware using SQL Server 2016 and Windows. This publication really highlights the overall performance benefits in SQL Server 2017. To follow on that result, HPE published another TPCH benchmark using SQL Server 2017 and SUSE Enterprise Linux Server. The unique aspect of this result is that it's a diskless database. HPE utilized their scalable, persistent memory technology. This benchmark had only 2 disks installed, one for the OS and one for SQL backup. This configuration resulted in 45% more performance with a 50% reduction in hardware costs and an 85% reduction in rack space. The details for both results are available on the TPC website at tpc.org. You can also find more information about HPE's scalable persistent memory at hpe.com. We have many more performance proof points and benchmarks scheduled throughout 2018 to further show the power and performance of SQL Server 2017. Thank you.